Steering feel, a common term thrown around by auto journalists when reviewing any car. Here's the problem, not many of these reviewers actually define what is meant by steering feel, and this problem is made worse, as good steering could mean different things to different people. To some, it could mean the steering being quick and responsive so the car points wherever you want it to go. But to others, it could be that the steering communicates a lot about what the tyres are actually doing. So, in our quest to understand possibly the most subjective term in the automotive industry, we will break down the components of what good steering feel actually means and why it is important for performance driving. Shortly after, we will then examine the differences between manual steering and power steering and how they can achieve good steering feel, as well as going over some steering geometry tidbits. Lastly, if you are currently unsatisfied with how your steering feels, we will provide solutions so that it can feel much better wherever and whenever you go. In our view at Intuitive, the term steering feel should be broken down into smaller chunks than just generalizing things and saying, "Oh, the steering feels really sharp when I'm turning through the roundabout." Let's list these categories down. The first component of steering feel that we'll discuss is related to steering feedback. In our modern era, when auto journalists review cars, you notice that most of them say, "The steering has next to no feel, it's so numb." Well, they're probably referring to steering feedback. What is this exactly? Well, it's where you feel your steering wheel shaking and vibrating a bit where you're driving at speed. It's a way for your steering to communicate to you information such as how hard your tyres are gripping and the texture of the roads that you're driving on. In that sense, a steering system that has good feedback will be able to tell if your tyres are wearing out and suss out changes in road surface from smooth to broken pavement. In most front-wheel drive cars, as the car has to both steer and accelerate, this crystal clear feedback in regards to those road surface changes or grip levels is often muted, especially in comparison to rear-wheel drive, as in a rear-wheel drive car, the front wheels are tasked solely with steering. However, there can be almost too much vibration in some steering systems, making it hard to control both in cornering and an overall unpleasant and fatiguing experience during daily driving, and we call this weird sensation steering kickback. The second aspect of steering feel is steering ratio. Pretty much, this is the ratio between the number of degrees the steering wheel turns and the number of degrees the front wheels turn. In a simplified scenario, a sports car steering ratio of 12 to 1 means that a 12-degree turn of the steering wheel will result in a 1-degree turn of the car's wheels. The less angle required to turn the steering wheel, the more direct your steering will feel. The steering ratio, as well as the number of turns lock to lock required, which is the number of full turns the steering wheel makes from the maximum left to the maximum right position, is usually kept low in sport compacts and performance vehicles to maintain this directness in steering. However, if your steering ratio is too high, likewise in most commuter and luxury cars at 20 to 1 and over, at low speeds, you would have a sensation we describe as the dead zone on center, or excessive play, which is your steering having a vague, unresponsive feeling at first when steering it a little bit in the middle. The final component of steering feel we'll talk about is related to how heavy your steering feels and whether the steering feel loads up in the corners as your car's speed and tire loads increase. A good steering feel should be one that feels heavier as cornering speed and tire load increases, but light when at slow speeds to park your car. To emulate this, manufacturers like to have a sports mode setting for the steering to artificially weight the steering and give the driver a rather misleading feeling of a meaty feeling steering system. We've now touched on the three main components of what steering feel means, but why bother with good steering feel? Well, let's take a current design philosophy that Mazda implements, known as Jinba Itai, which translates to horse and rider as one. This describes the connection between the horse and the rider, and here steering feel is that channel connection between the front wheels and the driver's hands, and the stronger the steering feel is, the stronger the connection between you as the driver and the car. This is because a good steering feel allows you to understand the car's handling nuances at the limit, and drive faster through corners and get better lap times. Although, good steering feel is not the only way of communication between you and the car. If that was the case, it'd be like talking to your partner in only Morse code. The uncorrupted steering feedback on some older steering systems could also help you adjust your driving style when on inclement surfaces like wet or bumpy roads. Speaking of which, let's now discuss the types of steering out there, from unassisted steering systems to modern electric power assisted steering. Let's talk about the most common thing all types of steering that we'll cover in this video have, and that is they have Ackerman steering geometry to some extent. You might ask, what is this? Well, because the inside wheel has to travel less than the outside wheel, so that uneven wear on the tyres as well as the tyre slipping sideways does not occur to ensure a more accurate and direct feeling steering system and accurate steering geometry. The inside front wheel would turn at a higher angle than the outside front wheel, with the inner wheel travelling slower than the outside wheel. With that being said, let's actually talk about manual steering. The most widely used form of steering by far is known as a rack and pinion steering system, which uses accurate steering geometry in some form or another. Basically, this uses a gear known as a pinion that moves a flat tooth bar known as a rack side to side to steer the wheels. This direct connection between your steering rack and steering wheel allows for this steering feel and feedback that lots of car reviewers love to rave about, as it ensures a linear steering ratio that allows you to pinpoint where your wheels are when you turn. And when you drive on more choppy surfaces, you'll get some very nice steering feedback, with the road forces from the front tyres being translated directly via vibrations to your steering wheel. When approaching corners at higher speeds, as the tyres would experience a higher lateral force that tries to push back on the steering, these lateral forces will be felt through the rack and pinion design on the steering wheel, increasing its resistance, making it heavier to turn at higher speed. Unfortunately, this unfiltered steering can only be found in the scarcity of cars in today's era, not limited to the Lotus Elise, Exige, and the Alfa Romeo 4C. Traditional hydraulic power steering systems used an engine-driven hydraulic pump to generate pressure, with an hydraulic force assisting the steering effort, making it easier to turn the steering wheel at low speeds. The key thing to note here is that steering feel is still maintained. This is as one, the steering wheel is still mechanically connected to the front wheels through that rack and pinion system we touched on earlier, so you still feel a sense of directness with the steering, as well as feel through the wheels things such as road forces and surface changes. And 2, many of these hydraulic steering systems are actually speed sensitive, so the faster you go, the harder it is to turn. Likewise to manual steering. Electric power steering. Basically, this is where your rack and pinion steering gets mounted onto an electric motor, and torque sensors and co will work overtime to communicate to the electric motor how much to assist you when turning. Most of the time, it's too much assistance. While it's great for the average commuter, as the drive now is dead easy, for us car enthusiasts, those 3 components start to fade away really quickly. To make the driver's hands not feel too tired after a drive, most EPS systems usually feel very numb as they dampen out those micro vibrations and road forces, which are that steering feedback which communicate to you what the tyres are actually doing, not where the wheels are pointing, which is actually something EPS is quite decent at with its emphasis on directness. Most of them often feel vague and overly light, even during fast corner entry, meaning there's a lack of build-up in the weight, as the EPS would have muted those higher lateral forces from the steering wheel. But there's a reason as to why EPS is used nowadays in a lot of cars, as opposed to hydraulic steering, with the last exponent being the late WRX STI. This is as it is much easier to get the steering to work in tandem with safety technologies such as lane centering and lane keep assist. But it's not all doom and gloom, with cases like Hyundai's N Division mounting the EPS system directly on the rack instead of the steering column in the i30N, Elantra N, and Kona N to get some of the unfiltered steering feedback and corner weighting back. With that being said, let's move on to the geometry that impacts steering feel. Camber, caster, and toe. 3 different flavors, but all are from the same ice cream shop. What do we mean by this? Before we delve deeper, let's review camber and caster from our previous videos. Camber is basically how much your wheels are slanted by if you look from the front of the car, and caster is how much your steering axis tilts by. But we haven't quite covered toe yet. No scorsy mate, don't get your hopes up. So what is it? Toe is basically how much your tyres are slanted by if you look from the top of the car. Now, these 3 stooges all play a distinct role in determining steering feel, with camber directly impacting the tyre contact patch during cornering, whilst caster impacts the self-centering of the steering wheel and how the suspension reacts under load to cause things such as torque steer, and toe affects the stability of the car and turning responsiveness, whilst also affecting tyre wear. So, if you want to improve steering feel by just adjusting these 3 stooges, how would you go about it? For the best feedback, you can use a combination of negative camber, positive caster, and toe out. Let's explain. As we know already, that negative camber tilts the top of the tyre inwards. The greater the contact package of tyres, the greater steering feedback, with more tyre forces from the road being transmitted through your wheel. Either camber bolts or camber plates will work, depending on your use case and car's front suspension. If you want to know in further detail about which best suits your needs, we recommend you check our understeer guide on our channel. Next, a positive caster basically allows for the steering axis to tilt backwards towards the driver to improve stability and self-center the wheels, ensuring on-center slop is non-existent and overall steering weight is better, with the driver feeling the resistance when turning. To achieve this, you can use either adjustable tension rods or offset caster bushes, and if you want to know which of these mods is the right one for you, check out our torque steer guide on our channel. Lastly, a toe out allows the car's front wheels to slightly angle outwards and point away from each other, and from a steering point of view, this improves two things. One, you get a much quicker and more immediate turn-in, so if your car has a high steering ratio, consider applying toe out to address that dead zone we talked about earlier. And two, you get improved feedback, especially during cornering, as toe out helps the wheels push against each other slightly, allowing the driver to feel the grip levels and tire forces as well as road surface changes. Well, you might ask how to get toe out. Again, Scalzi, calm down! Whilst you can adjust the toe via adjustable bolts that hold the toe arm to the rear subframe, the toe adjustments are limited by the range that the fitted eccentric washer provides. So to get a wider toe out angle, we recommend replacing your stock toe arm with an adjustable toe arm. However, too much toe out can be a bad thing, with your car feeling jittery and overly nervous on the highway. That being said, let's dive deep into other solutions which you can use to improve steering feel in your car. We must first address the root cause of steering feel, the rack. Though we all love a good rack, the first mod we'll touch base on is installing stiffer rack bushings. As steering rack bushings are engineered from the factory to be softer by using rubber, you get this weird slop and play in the steering, meaning a less direct and more vague steering feel. Stiffer bushings hold the rack more firmly in place, preventing this movement and making the steering feel more precise and direct during turn-in, as well as removing that muddiness from the steering slop to allow for more road information to be felt. These OEM rubber steering rack bushings can degrade over time due to typical wear and tear, which further exacerbates the sloppier steering. Stiffer rack bushings often use stiffer materials like polyurethane, Delrin and alloys. As for our recommendations, we recommend polyurethane bushings if you are trying to improve steering feel in your daily driver, as we are aiming to maintain a balance between comfort and steering feel, as PU improves steering precision due to be much stiffer than rubber while still absorbing some micro vibrations from the rack, with a hardness of 85 on the short A scale, compared to ethylene propylene's rubber's hardness of 40 to 90. If you have a weekend car that you primarily use for backroad driving, we recommend Delrin bushes, as they are quite a bit stiffer than PU, with a hardness of 70 on the short D scale compared to PU's hardness of 61. Now, if you are only intending to drive on the track and want the most communicative, precise and direct steering feel possible, we recommend alloy bushings due to their significant lack of vibration damping and high stiffness. From the data side of things, alloy or metal is much harder than elastomers such as rubber, PU and Delrin, so the Vickers scale is used instead of the Shore scale. The next mod we'll perform on the steering rack will be what is known as the steering rack lockdown. Likewise, the stiffer rack bushings, we want to stop the rack from moving under load, so we lock it down like COVID to rigidly secure it to the chassis, even during hard cornering or suspension travel. In this example, this parent steering rack lockdown for the GR86 consists of a bracket that stiffens the mounting points. Whilst this is excellent for improving steering directness and communication from those front tires, the caveat of this relatively cheap mod is that you feel more vibration through the wheel than you would say a PU bushing, so that it can feel rather harsh, especially if you're going on a road trip in a country like Australia, where chip seal roads are a common staple of freeways. Outside of the rack, there are other ways to improve the steering feel as well. For an option that's a tad costlier than stiffer rack bushings and rack lockdowns, you can replace the stock tire rod ends with proper spherical rod center tire rod ends. These use a spherical bearing instead of a traditional rubber or PU bushing that is usually attached to these OEM tie rods ends to improve steering directness and connection due to the reduced deflection or flex within the steering components. Keep in mind, these bearings shouldn't be confused with the ones used within the steering rack, as this is different to the rack. Lighter weight wheels from materials such as alloys, and in particularly forged wheels such as your typical TE37s are another great option to improve steering feel, although quite a bit costlier and not as significant of a difference maker as the previous 3 mods. But its effect should not be understated, however, as it decreases unsprung and rotational mass, improving that responsiveness and allowing more road information to be transmitted through your wheel. These can also make the steering feel sharper and more direct, especially if the car from stock has a higher steering ratio. And lastly, this mod is pretty frugal, however it only suits certain brands and can be quite complex to set up and install. In this case, we'll refer to BMW and the Bitmacode software. In certain cars such as the F87 M2 LCI, the steering feel was heavily criticized for being a step back from BMW's great hydraulic power steering systems of yesteryear in cars such as the E46 and E92 M3. So what many OG M2 owners did was swap the original ECU steering code via Bitmacode to either the M2 Competition or the M2 CS steering codes, and as those cars were designed to be more sporty than M2, using the famed S55 instead of a beefed up N55 and having a more aggressive steering tune which enhanced the steering feel, especially in the CS. With that out of the way, let's dive into the concluding remarks. Well, that's it. A guide to possibly the most misunderstood car term out there. I hope you've learned what steering feel is, which to many people can be quite confusing at times, as well as seeing its unfortunate decline into an increasingly more soulless and detached entity that is just there to do a job like quiet quitters, and now you can fix it. If you have any other ideas as to how to get better steering feel, leave in the comment. As I upload this video, it will be Christmas Day, so Merry Christmas and Happy New Year to you all, and I'll see you next year with some more bangers in store!